This is a nuclear reactor, and here's all the power it's producing accumulated into a single power cord. And because of this, there's a giant power outage right now, everything's all silent, and the authorities are onto me. Just ignore it. You know how much power this thing holds? Over a gigawatt of energy. That powers around like 700,000 houses. The fun part about that is...
all this
this
power
guy.
for us, too much!
You want to know what I'm gonna do with it? Yeah, I'm gonna charge. I'm gonna charge my phone. Yeah, that's right. This is the first step to $1 billion. A revolution in the concept of fast charging. Oh, my phone was just on 1%, and now it's on 96. 104. I didn't know it could get that hot. I don't know why I did that. It's not a Samsung. Oh, what? Oh, hey. Yeah, sure thing, officer. My hands are quite visible. Sad news. Can't sell this yet, but that was a lot of energy. All produced by this strange cylindrical structure. Why do these reactors produce so much energy anyways? What's the secret? Well, imagine a steam engine. You boil water with either coal or gas, whatever creates heat, and the boiled water turns into steam, of course. Now, steam is a gas, like air, and air can push things if it's strong enough. Same thing with steam. The steam pushes a turbine, which from here is able to convert the spinning motion into electricity through electromagnetic induction. So yeah, that's how people turn coal or oil into electricity. Now imagine this. Instead of heating water up with the same old, you do it with a nuclear bomb. It must be a lot of heat. Not like that exactly, but with what makes a nuke a nuke. Well, what makes a nuke a nuke? What's the science behind it? How does this egg filled with uranium create enough energy to blow up a city? Nuclear reactions. This is an atom, a very, very small particle. I mean very small. It's the smallest form of which an element can exist in. These are different atoms of different elements. Now, if we go a bit smaller, it's not oxygen anymore, but rather, these tiny things are called subatomic particles, which compose of protons, neutrons, and electrons. Yeah, these tiny particles, which are even tinier than the atoms, are what give elements their properties. Just the subtle difference in the amount of these tiny, tiny little things. Just a few more of them added here creates the difference between literal poison and gold. Now that you know about atoms, hopefully, let's look at the first type of nuclear reactions, which are fission reactions. For a typical nuclear reactor, the core produces heat by utilizing fission reactions, which is where a subatomic particle is launched really fast at typically a uranium-235 atom, as these guys split pretty easily, to which it splits the atom into different lighter particles. Now, when this happens, it breaks the bonds between the particles, which release energy in the form of heat and radiation. Like, imagine throwing a rock at another rock, and the other rock breaks, and you see how it releases energy in the form of heat? Like the sparks, of course, and sound. So, yeah, anyways, from here, from the force of the first reaction, these new lighter particles are launched towards other surrounding atoms, to which they split apart as well, and it keeps on going and going, releasing a bunch of energy in the process. This is called a chain reaction.